All right, let's get back. So a new section 8.3. Before we go this section 8.3, in fact, I want to temporarily skip this section here. We will come back to this 8.3 later. Let's go over 8.4 first. Let me see, do we have that section here? Let me double check that. Hold on. Did I miss something here? Yes, let's cover 8.4 first, everybody. So this is 8.2. We are using the z-test. Remember the z-test to do the hypothesis testing, 5 steps. So in other words, whenever to do the hypothesis testing, there are always 5 steps. The only difference will be you may use different formula. Remember in the previous confidence interval case, right? 7.1, 7.2, 7.3. It's all in terms of confidence interval, but they have a different formula. So this section here, 8.4, is very special. It's special for what? Proportion. Remember, for the confidence interval, we also have a special section for that, right? Proportion, given 2 numbers. Same as here. Example number 1, given claim. They are trying to study this one, claim 60% of people avoid transfer fat in their diet. So that's the hypothesis they are trying to get. So to either prove this or disapprove this, you need to get a sample, right? So we have a sample of 200 people. Out of these 200 people, they find out 128 people avoid transfer fat. So at alpha equal to 5%. So in other words, confidence is 95%, right? Is there enough evidence to reject the claim, right? So what do we do? The same 5 steps, everybody. Step number 1, write down H0, H1, right? So H0 always equal, The only difference here, we change the letter a little bit. Previously, we always use mu for average, remember? But this case here, we change to P. Why we change that? Because this section here talking about proportion, percentage. So we have the formula in terms of P hat. So that's the reason we are switching to P. Now, H1 here, because we did not say it's bigger than 60% or less than 60% by default, not equal to, right? All right. So number 2, find out the test statistics. So we are using the different formula here, everybody. It's actually, you might have seen similar formula previously in the confidence interval case, right? So it's a Z formula. So we are using the P hat minus P divided by square root of P multiplied by Q divided by N. Everybody, let's go over each one so you don't get confused. What's P hat first? So P hat, next time, whenever you see something about hat, right, that reminds you, whenever you see the P hat, that means this number is coming from some sample estimate. Whenever you see that, it's coming from some sample estimate, right? From what? From the proportion in this particular case here, out of the 200, 128, that's the proportion divided by 200, which is 64%. Those people avoid transfer fat, right? So what's in that case? If we want to find out the Q hat, will be 1 minus P hat, right? What's the N? Everybody, sample size here. Be careful. N is not equal to 128. N is the total of 200. Now, in the formula, I want to mention one more thing here. You see that denominator here, right? This one here is PQ. It's P multiplied by Q. It's not P hat, Q hat. Everybody? This is a common mistakes. If you want to write down this on your notes, okay? Here should be PQ, not P hat, Q hat. So in other words, when we plug those numbers here, everybody, P hat, numerator, right? P hat is 64%. We calculated, we got that. Minus P, where do we get this P? We got this P from H0. Remember? In the H0, we always have equal. I mean, that's the reason, right? Otherwise, we cannot plug those numbers in the formula, right? So P is 60%. What's Q? Q is 1 minus P, which is 40%. You see that here, everybody? Okay, one more time here in the numerator, the formula is P multiplied by Q. It's not a P hat, Q hat in the denominator here. Follow me? It's very, very important. Now, let's continue our calculation. We find out 1.15 here. Find out 1.15, right? That's the number 2, doing the calculation, the test of statistics. Number 3, find out the p-value. How do we find out the p-value? It's determined by hypothesis, H1, is it right? What's H1 here we have? H1 here we have not equal to, is it right? So H1 here is the not equal to. So that means what? It's two-side. It's two-side. Once we find out this 1.15, right? We find out like to the tail. What's next? That reminds us this area. Also, we have to include the other side because H1 is what? Double side. Two-tailed, two sides, right? So we are going to double the area. Each side here, if you find out from the Z table, is about 12.51%. Double that, 25%. That's pretty big. That's our p-value, right? So remember, if the p-value is small, it's less than alpha, what do we say? Everybody, can you type this on the message window, right? If p-value less than alpha, what do you say? Everybody, I'm trying to see who did not type. Okay, reject. That's right. That's right. Reject what? Reject HO. Right? Yep. So in this case here, I mean, you remember that, right? If p-value less than alpha, reject HO. Now, how about the opposite? If p-value bigger than alpha, what do you say? Not reject, right? Not reject. Not reject HO. Okay, so that there is not enough evidence to reject HO. That's step number 4. Number 5, translate that into human being language. When we say not reject HO, that's equivalent to say not reject HO. That's equivalent to say accept HO. HO is right. Why do we care about the HO? HO is the claim. So in other words, yes, we do have 95% of confidence to say 60% of people avoid transfer fat in their diet. We have 95% of confidence to say that. Is that clear? So that is the using the proportion formula, this formula here, to calculate the hypothesis testing, the test of statistics. Right, that's example number 1. Example number 2. Claim less than 77% of people oppose replacing the dollar bill by the dollar coin. I mean, you see sometimes if you try to confuse people, usually use the double negative, is that right? It's like they say less than 77% of people oppose, they don't like this idea, right? I mean, if I'm trying to translate that. So, but it's less than. That's a little bit tricky, right? Okay, so to either support this claim or disapprove this claim, sample. Randomly select 80 people, we find out 55 people, they don't like this idea, right? So at alpha equal to 1%, so the confidence, 99%. Is there any enough evidence to reject the claim, right? Is that claim true or false, right? So everybody, H0 always equal. Proportion, is that equal to 77? Because that's the one we are trying to compare, right? Now H1, I write down less than 77%. Why is that? Because in the claim, that's the one we mentioned in the claim, less than 77%, right? So that's easy, right? Number two, doing the calculation here. So we are using the z-test, right? We write down all the calculations. P hat is the proportion coming from the sample, right? Coming from the sample, 55 out of total 80. That'll give us 68.75%. So we put this number here. So what's the P? This P here is coming from where? It's coming from H0. Remember, always H0, right? Same as the denominator, do not forget here is PQ. It's not P hat, Q hat. All right, so 77% for P was Q. Q is 1 minus P, right? So we find out a negative 1.75. Negative 1.75, what's next? We try to find out what's the p-value, right? What's the p-value? Remember, the p-value determined by what? By H1, right? Is that on one side? Is that to the left, to the right? One side, two side, determined by H1. So negative 1.75. We can draw the bell-shaped curve, right? Always do that, everybody. On the homework, on the exam, right? On your paper, draw that. You know, slow is fast. You don't make mistakes when you draw that right down, right? So in this case here, we have negative 1.75. Do we care about this side here, or do we care about the other side, or do we care about both sides? Here, because less than tells you we only care about to the left. Is that right? We don't care about this piece here. So from the z-chart, you find out about 4.01%, right? So now we compare with p-value with our alpha, right? Remember, if p-value less than alpha, what do you say? I mean, from the message window, it's reject, is right? Now, the other word, the other side, the other way. If p-value is bigger than alpha, what do we say? Not reject. Not reject what? Not reject HO. Back to the statement here. When we say not reject HO, that means what? That means reject H1. Why do we care about H1? H1 is the claim. The claim, they say less than 77%. So we are going to reject H1. This claim is not right. So we have 99% of confidence to reject this claim. We have 99% of confidence to reject this statement and say less than 77% of people, they don't like this idea. Is that clear? Let me erase that. Okay. One more example, then we take a break. All right. Example number 3 here. Similar. So claim more than 25% of all lawyers, they do advertisement, right? So they want to see, is that true or false? More than 25%, right? So we randomly select 200 lawyers, find out 63 of them, they have done advertisement, right? we want to test this claim at alpha equal to 5%, right? Remember, most of the time we talk about the confidence 90%, 95%, 99%. Corresponding alpha is either 5%, 1%, or 10%, right? Now, step number 1, write down H0, right? This case here is a proportion. So we are using P is equal to 25% or H1. I write down here, P is bigger than 25%. Why is that? Because it's mentioned in the statement, right? So that's our first step. Number 2, doing the calculation. So we want to find out the proportion from a sample, 63 out of 200. So that's 31.5%, right? When we plug this one in the formula, 31.5% minus P, where is this P coming from? Coming from HO here. It's HO here, right? So 25%, what's Q? 75%. Do the calculation, 2.12. So 2.12 here. Do we have to, number 3, find out P value? Is that a one side or is that two side? Right? Determined by what? H1. H1 is bigger than, that means what? To the right. Only one side. So that is about 1.7%, everybody. Right? I assume everybody knows how to use that Z table, right? So now we find out the p-value 1.7% compared with alpha 5%. Everybody, if p-value less than alpha, what do you say? Reject. Reject what? HO. Reject HO. That's equivalent to accept H1. You see that statement? Reject HO, that's equivalent to accept H1. H1 is right. Why we care about H1? H1 is the claim. Remember, at the end, we are always trying to make a conclusion in terms of a claim. So now, we reject HO, we accept H1. The claim is right. More than 25% of lawyers, they do advertisement. We have 95% of confidence to say that. That's step number 5. So we always want to translate into a human being language in the last step, right? Last step. And always make a conclusion in terms of what? In terms of a claim, the claim.